Numbers of problems based on fundamental principle of counting. So now what does permutation says? It says that permutation states that if there are n different objects, taking R objects, if there are n different objects taking R objects at a time, then permutation is given by NPR, where P represents permutation, and the formula of permutation is nothing but n factorial by n minus r factorial. This is the formula for permutations. If there are n different objects and we are taking r objects at a time, then the formula of permutation is given by NPR. So let me take a few examples to find the value of NPR. Find the value of 7p2. 7p2. So what is our formula? N factorial. So what is the value of n here? It shows that the n value is nothing but 7 divided by, what is the denominator? N minus r factorial. So n value is 7, r value is 2. So it becomes 7 factorial by 7 minus 2 is 5 factorial. So we can break it 7 into 6 into 5 factorial by 5 factorial. 5 factorial cancel, 7 6 are 42. This is an example of permutation. Let me solve one more problem. 15p3. 15p3 is nothing but 15 factorial by 15 minus 3 factorial. So it becomes 15 factorial by 12 factorial. So which is equal to 15 into 14 into 13 into 12 factorial divided by 12 factorial. These two gets cancelled. 15, 14, 13 if I multiply, I will get 2730. So this is the basic introduction of permutation. We will be solving the numerical problems in the next video. Now what is left? I was about to talk about the factorial value. Prove that factorial, what was the question? Prove that factorial 0 is equal to 1. Prove that factorial 0 is equal to 1. This was my question. So we know NPR is equal to factorial n by factorial n minus r. What do we know? We know NPR is equal to factorial n by factorial n minus r. What does factorial n indicates? It indicates product of n natural numbers. N natural numbers, or I can write this as n factorial is equal to n into n minus 1. I am reducing the problem. Now let us consider n equal to 1. So if I take n equal to 1, it will become factorial 1 is equal to 1 into 1 minus 1 and 1 minus 1 factorial. So this will become 1 factorial is equal to 1 into 0 factorial. So 1 into 0 is nothing but 0 factorial, and the value of factorial 1 is nothing but 1. So from here we come to know 0 factorial is equal to 1. Okay student, this is the simple value of 0 factorial is equal to 1. So these are the basic simple permutations. We will be solving more and more problems in the next video. Now I am going to solve some problems based on fundamental principle of counting. Let me take some example. Fundamental principle of counting. Question is, if repetition is allowed, how many even numbers of two digits can be formed with the digit 1, 2, 3, 4, 5. What is the question? If repetition is allowed, means you can use the value whatever you have used in the previous case, that value can be used again in the next case. Is allowed how many even numbers? What type of number we have to form, students? We have to form even numbers, and even numbers of two digits. So what we have to form? We have to form even numbers, and the numbers are two-digit numbers. Okay student? Now what are the digits given to us? Total number of digits given to us are 5. What are these 5 digits? That is 1, 2, 3, 4 and 5. Okay student? So we have to make two-digit number. So I am making 2 boxes. Okay? So I am making how many boxes? 2 boxes. Generally what do? We start filling the digits from the right side. We can also fill the box from left side. There is no matter from where we are filling the box. There is no such condition. But since we have to make two-digit number, so there should be ones place and tens place. They have given a restriction. The restriction is we have to make even number. So students, even numbers are generally categorized by its ones place. The ones place only gives the information, ones place gives the information whether our number is even or odd. Based on ones place, we can recognize whether our number is even or odd. So from here we can see what are our even numbers. Our even numbers are 2 and 4. So if I have to fill the ones place, I can either use here 2 or 4. So ones place can be filled by two ways. Ones place can be filled by two ways. Since repetition is allowed, suppose I have used here 2. So since repetition is allowed, this 2 can again be used in this place. Okay, student? So how many digits are present? Total there are 5 digits. So this place can be filled by 5 ways. I am repeating it again. Since we have to make it 2-digit even number, so our first work is to fill the ones place. So ones place can be filled either by 2 or 4. So total ways here is 2 ways. Since there are 5 digits and I have already used one of the digits in the ones place. Now how many digits are left? 4 digits are left. How many digits, student? 4 digits are left. 4 digits are left. But since in the question repetition is allowed, so whatever I have used in the ones place, that number I can use it again in the tens place. So earlier it was 4 digits. Now if I take the digit, it becomes 5 digits. So this tens place can be filled by 5 ways. So by fundamental principle of counting, total arrangement is equal to 5 into 2 equal to 10 ways. So I think you have been cleared enough. Let me take one more example. Same type of the question is, without repetition, how many 4-digit numbers can be formed with the digit 1, 3, 5, 7 and 9. Here repetition is not allowed. Without repetition means we cannot use the value again. So how many days we have to make? We have to make 4-digit numbers. So let me make 4 boxes. So we have to make 4-digit number. And our total digits are 5. The 5 digits are 1, 3, 5, 7 and 9. So here they have not given any foundation that we have to make either even number, odd number or anything. Simply we have to make 4-digit number. So how many digits are there? There are total 5 digits. Let me start filling from here. I can take any one of the digits from here, but I have total 5 options, means 5 digits are there. So this place can be filled by 5 ways. Since I have utilized one of the value here, suppose I have used 1 here. In the first box I have utilized 1. So now remaining how many digits are there? Yes, correct. There are 4 digits. Now from that 4 digits, I will be placing any one of the digits in this particular box. So to fill this box there are 4 ways. Similarly, one more value is reduced from that particular 5 digits. So now remaining how many digits are there? There are total 3 digits. So this can be filled by 3 ways. In the same way, this can be filled with 2 ways. So what does fundamental principle of counting says? By fundamental principle of counting, total arrangement is equal to multiply all the numbers 5 into 4 into 3 into 2 is equal to 5 4s are 20, 20 into 6 is equal to 120 ways. Okay student, so that's all for today. Thanks a lot.